Okay, so number 2, which of the following tables represents the linear relationship shown in the graph? So the first thing you're going to do is highlight the y-axis. That is just so you don't forget which one is y. Sounds really simple. I won't forget. Trust me, we forget all the time, all of us. So one of the easy ways to do this is just pick a spot on the table and see if it falls in the line on your graph. So if we pick a nice easy spot here for table A, that is 4, 6, x, y. We're going to start at 0 and we're going to go positive 4. And then we're going to go positive 6. Is that spot on our line? It is not. So table A is not our answer. So looking at table B, let's pick a different spot. Let's pick this 6, 4. It's nice. Starting at 0, we're going to go sideways 6, positive. Then we're going to go positive 4. That is totally on our line. So we can either prove that the rest of B is correct, or we can prove that C or D is wrong. So let's look at C and D. If we look at C and D, we know 6, 4 is correct, and they actually both have 6, 4. And all 3 of these have 3, 0. So checking 3, 0 isn't going to help us either. If we look, B and C have 0, negative 4. So if we check that, we can see if D is wrong, 0, 4. So let's check 0, negative 4. So starting at 0, we're going to go 0 sideways. And then we're going to go negative 4 down. That is on the line. So D is wrong, because D has 0, 4. So the only thing left for us to check is this negative 3, negative 8, or 3, 8. So if I'm going to check this 3, 8, it's 3, 8, x, y. Starting at 0, I'm going to go over 3 and up 8. That spot on the line? No. So our answer has to be B. Now you're looking at 3. So first things first, highlight your y-axis. And you can circle your y-intercept when you do that. This right here is where the line crosses the y. So that is a positive 2. So if we're looking at y equals mx plus b, the plus b has to be a positive 2. So if I look, I can cross off B and C because they have a plus 3 and a negative 2. The next thing to check is if my line is positive or negative. So if I take my hand, my left hand, and put it on the line, am I pointing up or am I pointing down? Truthfully, you're pointing up, right? So B has to be positive. Now, that alone will give me my answer, knowing the y-intercept, and if it's positive and negative, I'm done. But just in case, I would like to check another way. I'm going to pick the one I think it might be. And let's check A. So A is y equals negative 2x plus 2. I'm going to pick any spot on the line and put it in to see if it works. So let's say I choose 5, 6. So I have y equals negative 2 times positive 5 plus 2. Negative 2 times 5 is negative 10. And negative 10 plus 2 is negative 8. So if I plot this point, when x is 5, y is negative 8. Is that spot on the line? It's not, so A is not right. We can double check D just to prove to ourselves. Let's go ahead and put our positive 5 in there. Now 3/5 times 5. Do this, you will find out that the answer is 3. So when x is 5, y is 5. Let's see if that could be true. So positive 5. I don't know if it's quite exactly true. But it's a lot closer than A was. So we're going to stick with D as our answer. So in a table, how can you tell if the rate of change is positive or negative? So I'm going to help you start this. In the table, how can you tell if the rate of change is positive or negative? You can tell if the rate of change is positive or negative in a table. Remember, rate of change is the same as constant. So if you -4 to 0 is 4, and 0 to 3 is your answer going to be positive or negative? Positive, right? They're both positive. So if you do the same for C, 3 to 6 is 3, 0 to 4 is 4. Positive or negative? Positive. Okay. Which of the following graphs is represented by the linear equation y equals 2x minus 3? So first of all, highlight all those y-axis. Axes. I don't really know. Now, our -3 is our y-intercept. So if you circle where the line crosses the y, it has to be at -3. If it's not, the answer is not right. Now, the other thing you can check is if m is positive or negative. All of these graphs are positive. If you put your finger, your left hand, on all of these lines, it points up every single time. So that doesn't help us. We have to substitute for this one. So if we have y equals 2x minus 3, oh, it disappears. Hang on. Y equals 2x minus 3. And I pick a spot on my line and substitute it in, it has to give me the right answer. So for A, my spot can be 2 and 3. So 2, 3, x, y. Two times 2 is 4, minus 3 is 1. Does that work? Because if x is 2, my y has to be 3. Is that true that 3 equals 1? So it's not A. Let's try table C. Let's do this one. We've got 4 and 5. So y is 5 and x is 4. So far, so good. Let's check out B. Let's do, this one's tough. 8, 1. Oh, yep, I forgot it disappears there. I don't know why. We'll do it over here. Y equals 2x minus 3. We said we have 8, 1. So 1 equals 2 times 8 minus 3. Is that true? 1 equals 13? Nope.